I said everything gonna be alright. I said everything will be alright.
Everything's gonna be alright. Good day wherever you're listening from, and welcome to Indoor Air Quality Radio, IAQ Radio. It's Friday, January 13th, 2017. This week is episode 443. My name is Radio Joe Hughes. I'm coming to you live from Studio D in Central City, Pennsylvania. At the controls is our engineer, John. You gotta have faith. And joining me from Studio C back in McKees Rocks, Pennsylvania is Cliff the Z-Man Zlotnick.
Hi, Joe. Hi, John. Hello, everybody.
Okay, and this week we welcome Cliff Cooper. We're going to talk a little bit the Vertex companies. He's with the Vertex. He's their industrial hygiene, senior industrial hygienist, and we're going to talk a little bit about IAQ investigation methods, talk a little bit about some green building stuff, and looking forward to a great interview. Before we get started, though, we have to stop and thank our marquee sponsors.
We could not do the show without our sponsors, beginning with our marquee sponsors.
Jon-Don Products, where restoration and abatement contractors shop. Visit them at jondon.com. That's JONDON.com.
Healthy Indoors Magazine, a free online digital magazine for industry professionals and consumers. Subscriptions are available at IAQ.net.
Legends Environmental Insurance Services, the experts in insurance for environmental consultants and contractors for over 20 years. Visit them at legends-enviro.com. Please be sure to thank our sponsors for their support of IAQ Radio when you inquire about their services or products. And last but not least, please visit the IAQ Training Institute website for the most current dates for the training you trust at IAQtraining.com. Let's turn it over to the Z-Man for today's IAQ Radio trivia question.
Thanks, Joe. Win a cool prize by outcompeting fellow IAQ Radio listeners and being the first person to correctly answer the IAQ Radio trivia question each week. Submitting your answer is easy. Either email it to czlotnick@cs.com, or if you're listening to the show live, you can text in the answer via your computer. Congratulations. To John Lapotere, IAQ Solutions, Orlando, Florida, for the first correct answer to last week's IAQ Radio trivia question. The IAQ Radio trivia question for today, Friday, January 13, 2017, has been sponsored by Ideas, the solution chemistry company, creating unique solutions to odor removal, surface cleaning, and decontamination problems. Now for today's IAQ Radio trivia question. What is the air sampling accuracy of the true value given the airs during calibration, sampling, and analytical methods? Back to you, Joe.
Good one, Cliff. Okay, today's guest is Mr. Cliff Cooper. Cliff is a certified industrial hygienist and serves as the senior industrial hygienist with Vertex Companies, Inc. They are a 400-employee firm and global provider of construction, environmental, energy, air quality, and engineering solutions with over 20 domestic and international offices. Among his current responsibilities with Vertex is to lead the Air Quality Services Tracer Laboratory, which was established in 2015 with an applied research grant from the New York State Energy Research and Development Authority. He has long served as a principal investigator and team lead for chemical safety, biological safety, and indoor air quality consulting. He also has a long history of contributions to the sustainable building movement, including 4 years of service on the board of directors of the New York Upstate Green Building Council, the US GBC program reviewer, and a speaker on IAQ and wellness aspects of green buildings. He's also got a strong building science background with BPI certifications and other building science related experience, and education. Welcome, Cliff, with some music this week. For those of you that, like me, don't know what that's from Friday the 13th. Thank you, Cliff. And today is Friday the 13th. And welcome, Cliff. It's great to have you on the show.
Thank you, Joe and Cliff. I'm really happy to be here.
We really appreciate it. I've seen you, I haven't met you in person yet. I look forward to doing that at the 20th annual IAQA conference, or annual meeting they call it, I guess, coming up in Las Vegas at the end of the month. I guess it's like the 31st, 30th through the 2nd or something like that. Folks can go to the IAQA website to find out more. But you've been around for quite a while doing industrial hygiene, but I always like to talk to guests about, what led to your initial interest in industrial hygiene and then indoor air quality issues?
I actually started in indoor air quality before I got into industrial hygiene. I got my master's degree in environmental science with work on outdoor air pollution science. I did a stint with Los Alamos Laboratory trying to understand what the air quality impacts of energy development in the Rocky Mountain West would be, primarily on these pristine areas, national parks, national mines. And then I got a job with the Washington State Department of Ecology as a smokestack tester, and then as an environmental professional for the siting of major energy projects. And one of those projects was a 2,000 megawatt coal-fired power plant, and I was charged with developing the air permitting for that facility, and part of that was modeling what the impacts would be. And I presented that work in an Air Pollution Control Association conference in Montreal in 1984, and there were a group of us young professionals in environmental work were there, and one of the people there reported that EPA had just published what they called the TEAM study, Total Exposure Assessment Methodology. And it showed for the first time that air pollution could be worse indoors than outdoors. And I had been frustrated by using these models to try to determine what the impacts were from a smokestack on, say, an Indian reservation 20 miles away, and how it's such an inexact science, and realized that if I could study pollution in a box, it would be just so much easier. And I just thought that indoor air quality would be so much easier to study than outdoor air quality, that when I got back to back home, I just started working on indoor air, and that's how I got started. Just because I thought that it's easier to control that environment than it is outdoors.
Where is back home for you, Cliff?
Say it again?
Where is back home? Is that New York? Are you from New York originally?
Yeah, I'm originally from New York. I spent many years in Washington State working for state government there, and then consulting there before returning here to the Northeast. But I've been here now since about 1996.
Okay. And you had your own private consulting practice before getting in with Vertex. Is that accurate?
Yeah, I did. I had an easier time working for myself than companies. Mostly by myself, but stints with others, including IBM and ABC, Disney. But always coming back to my own practice.
So you've been around a little bit. Now I'm wondering, you back in '84, mid '80s, let's say, you were doing outdoor air and thought, this indoor air thing is going to be a big thing. Did develop as quickly as you expected back then?
It really did. Starting with the team study, and then of course, what happened with the first energy crisis. They started building buildings without any outdoor air intake at all. In the initial energy conservation, they started using sheet poly barriers in building envelope walls and building buildings without outdoor air distribution, and this issue of sick building syndrome exploded onto the scene, and then formaldehyde came in as an issue. So it happened very rapidly. I had once I started getting into indoor air quality, it was easy to make it a full-time profession.
And then, when did you get into the industrial hygiene end of things? Was that right after college, or take a little longer?
Well, yeah, it took a little longer. I actually got into industrial hygiene when I returned from. I got into industrial hygiene as a sort of a natural progression. I opened up a laboratory at my alma mater at Washington State University, and ended up developing the first EPA accredited laboratory for radon testing in EPA Region 10 in association with the university. And I started doing forensic work through the university. The university would get requests. It was a land-grant college, and they would get requests for environmental investigations that they would turn over to me as a company in their research part. And so I started doing these forensic investigations, and that's how I got into this industrial hygiene. And then finally got my CIH, 10 years later.
I see. Now let me move over to the. You mentioned forensic investigation. Vertex does a lot of construction defect type work, construction testing, etc. Talk to listeners a little bit, if you would, about the trends in that area. Is your work dominated by moisture and mold issues, or is that just a small niche part of what Vertex does?
Yeah, Vertex is primarily a civil and structural engineering company, and but we have an indoor air quality services arm. We have a more recently developed arm in providing forensic support services for insurance clients to provide science and engineering support for construction defect litigation. So a lot of our work has to do with construction defect and property damage, as well as brownfields work. My work as an industrial hygienist and as an indoor air quality professional has a good part of it has to do with damage conditions in buildings, and of course moisture damage and mold is a big issue. I like to say that years ago when I got into this business, I would get a call from a client, and they would say, "We've got occupants in our building that are reporting dissatisfaction with the air quality in the space, or health effect or discomfort." And then they would ask, "Can you come in and see if there's something in this building that could be associated with that?" Today, you get a similar request. We've got occupants that are experiencing dissatisfaction with air quality, but then they say, "Can you come in and test for mold?"
Yeah.
And so we get a lot of that, where the assumption is that if there's an indoor air quality issue, that it's related to mold, and mold has become a cause célèbre. There's a lot of publicity about it, and people think that if there's an indoor air quality problem, it must be mold. So the perception is often different than the reality.
Got it. Cliff, let me turn it over to you. Z-Man, I got to keep that straight today. I got two Cliffs.
Yeah, I guess, Cliff, what about legal action in the past 5 years? Has it, on the forensic side, has it increased, decreased, or pretty much remained about the same?
Yeah, from my own perspective, my involvement in these in lawsuits has steadily increased, and So from my perspective, it's gone up. But I asked some other people in my company to get a sort of a broader perspective from the company, and the word that I get is that a lot of this litigation, building litigation, happens with it's almost a standard procedure that you at the end of construction that there's litigation in building construction, and it's more related to the volume of construction than it is to any change in procedures that are happening. And as we're getting into more complex buildings, sustainable buildings, the question is, are we seeing any difference in litigation? And the word that I'm getting back is that in the late 90s up to 2000, there was a big construction boom, and so and typically the liability is about a 10-year window for liability to file a claim based on construction, and with the recession it resulted in a lot less construction. So our company is seeing less litigation now, but we believe it's from much less construction in the last 10 years since the 2008 recession, and so it's related to the number of buildings being built more than it is to any of the techniques that are being used for building these buildings.
That's interesting. I'm glad you checked with the other folks. That's very helpful, I think, for listeners. And I think maybe, I don't know if you agree, but do you think the group feels that the litigation will start to pick up again? Because over the last, 6-8 years, we've seen an increase in construction.
Yeah, I think we all do, because I think that the same problems are occurring that have plagued construction in the past. And now we have this added burden of sustainability, of having a higher performance, greater complexity of building. So I think as long as we don't change the program for how we build buildings, we're going to see the same outcomes. And the outcomes are, more often than not, at the end of the construction process, you go from construction to certificate of occupancy to litigation, and I don't think we're going to see that substantially change.
Z-Man, jump in here.
Yeah, thanks. Cliff, I wanted to get your comments. I was involved in a project in New York. It was in a very high-rise building that was new. It was under construction. And what they were doing is they were actually hanging drywall, finishing lower floors before they actually had a roof on the building. So every time it would rain, water would, come into these buildings. And, as you're located in New York, I'm just wondering whether you're seeing the same thing and why they can't figure out how to prevent some of that water intrusion during construction.
Yeah, it's a good question, and I've seen it myself, where they start bringing in a gypsum board before the building envelope is complete, and absolutely correct, hanging drywall before the building before the windows are in. And so it's subject to storm events and that sort of thing. There's all kinds of conditions happen during construction that could damage these materials, these finished materials. And the issue that I see often is that as the trades are sequenced into this construction project, nobody has responsibility for reporting issues. It's all up to the site construction manager, who's already got a full-time job with sequencing the trades, getting materials in, to be able to do a walkthrough of the construction site every day to see what's going on here. And so if it's not reported that there's been flooding on a floor and there's water wicking up the chipboard, and that chipboard needs to be removed, if that's not noticed and taken care of before the painting contractor comes in, that's going to be painted over, and it's not going to be removed. It's going to be set in place, and it's going to be a problem in the finished building. it's not an uncommon problem. There are solutions for it. We have clients that have indoor air quality during construction management programs that are put in place. We have insurance companies that are requiring that in some cases as well. The solution is that there should be somebody whose responsibility it is to routinely walk the project site and look for problems that could occur during construction that could affect the finished project. And where that happens, I think it pays for itself, and it happens at times, but it doesn't happen all the time.
I've got a quick question, then I want to take a short break for like a little transition. I do have one quick ad I want to play as well. But, I had a question developed here about litigation on green buildings, but then in a correspondence back from you, I noticed that, that maybe isn't the right question. And you indicated that in your experience, and you do a lot of green building work, there are two basic types of green building projects, and that one works much better than the other. Could you kind of summarize your thoughts on that for listeners, Cliff?
Sure. So it's the building owner really has a tremendous responsibility for the outcome of the building project. And if the building owner is just interested in getting the LEED certification, I want my project to be LEED Silver, and otherwise the project, it goes according to a standard linear construction project, it's not going to be any better, any less likely to be subject to the problems of standard construction, and actually could be more likely because you're adding an overlay on a standard construction project of saying this overlay is that we want the LEED points. We want sufficient LEED points in order to have this project certified as a LEED project. The alternative to that is where the building owner says, we want to accept this concept of sustainable building practice and internalize this into the project, that we actually do want a sustainable building. And rather than chasing the points, they're accepting this concept of sustainable high-performance building design. and the recommended practice by ASHRAE, by the AIA, is it's what's called integrated building design, where you do much more upfront programming for the building. And the owner has to have very specific objectives, concrete, solid performance criteria that he builds into the design intent of the building that have to be met by the contractors. And if all of that upfront work is done right, even then there's problems when you bring in inexperienced contractors who are not familiar with this integrated building design process. But if you get them all right, if you get experienced contractors in, you get an architect who's committed and an owner that's committed, then you can have a very good outcome. But again, it's not guaranteed just because you're going for your LEED certification.
And a lot of times I would imagine when they're going for the LEED, they want to do it as inexpensively as possible as well.
Well, right. They want the points, but they don't want to change the budget to get those points.
We want the points, but we don't want to pay more for it. All right. Hey, this looks like a good place to stop and thank one of our sponsors. Talk a little bit about an upcoming event Cliff and I will be a part of, the Z-Man.
It's the second annual Indoor Environmental Science Forum, coming to the DoubleTree Hotel, Tampa Airport in sunny Tampa, Florida, February 21st through the 24th. Join industry leaders and educators as they share their knowledge and supporting science with you. See the latest equipment and solutions from exhibitors. Network with sponsors and industry insiders. It's 2 full days of in-depth coverage of water damage, assessment, protocols, mold remediation, solutions, and legal issues. Don't miss this important 2-day industry forum, beginning this February 21st with a welcome reception and wrapping up with a live IAQ radio broadcast Friday the 24th, featuring Radio Joe and the Z-Man and their guest John Lapeterre, Richard Alexis, and industry watchdog Pete Consigli. Register now at indoorenvironmentalscienceforum.com or call 954-562-6093 for more information.
And the Z-Man and I hope to see a lot of listeners there. Let's get back to our interview with Cliff Cooper here. Cliff, I want to change gears just a little bit and go into more of the title of the presentation or the interview that we put out today, and that was IAQ investigations. You're going to be doing a presentation at the Indoor Air Quality Association's IAQA's 20th annual meeting called IAQ Investigation Methods. And I wanted to ask you to, if you would, without giving away too much of your presentation, can you summarize for listeners what kind of things you'll be talking about, what some of the key points are that you want people to understand coming out of that presentation?
Yeah, sure. One is that this industry that we have, that the Indoor Air Quality Association is representing, is sort of evolved from where it was 10 years ago. 10 years ago, we had industrial hygienists or environmental scientists or health professionals going into buildings and with no building science knowledge, but with their science knowledge and their industrial hygiene knowledge, but without that building science knowledge. With this Indoor Air Quality Association and the membership of this association, we're finally bringing in people with real building experience into this idea of evaluating the function of a building to provide a healthy and comfortable place for occupants. Somebody who actually understands how buildings work. And so what I intend to do with this little 2-hour workshop is to provide insight to this group who I expect already has a good knowledge base in building science, to some of the nuances of the industrial hygiene aspect to building science. And I really think that we're starting a sort of a golden age of indoor air quality with being able to integrate building science and environmental science to provide a profession that can evaluate building performance in terms of occupant well-being. So that's the overall. I'm going to start by, first of all, the elephant in the room. Indoor air quality investigation versus mold investigation. Let's get that out. Let's describe what those differences are. And the second is indoor air quality investigation versus health and safety investigation. What are those differences? It's not mold investigation. It's not health and safety investigation. It's indoor air quality investigation. And how do we define that? So that's where we would begin. And then, it gets into what the basics are of an indoor air quality investigation. What's the primary information that somebody should be looking for when they walk into a building? And the only information they have when they walk into the building is that somebody is reporting a problem. How do you begin? How do you do this? Too often, people come in with all kinds of equipment. They come in with their CO2 meters, their CO meters, their VOC meters, their particulate meters, their mold spore traps. And they'll go to the occupied space where the occupants are reporting dissatisfaction, and they will test around those occupants. And that's not an indoor air quality investigation. There's a difference between inspection and measurement. And the most important thing you do in an investigation is the inspection. The measurements are the bells and whistles, but it's that physical inspection, and that's what we'll focus on in this workshop.
I really appreciate. I'm glad you came on because both of those things are the first observation you made is very interesting to me, and I'm glad you feel that way. That there are people in the IAQA world that are good. You know, they understand buildings. Some of them come from the restoration world. Some of them come from the home inspection world. Some of them come from the old asbestos and lead paint, industries. And they've been around buildings. A lot of them are mechanical people, that have done mechanical contracting type work. And now they're adding. So I really like that foundation that you're building on there. And then, we at IAQ Radio have emphasized the second part of your presentation there over the years, that and especially the idea that not everything is a mold problem. I'll never forget Wayne Baker coming on and saying that if all you have is a hammer, everything looks like a nail, and that people have to stop thinking about mold. It's indoor air quality, or at least look at the overall indoor environment. I'm curious, have you been to any other IAQA conferences or local chapter meetings, and what were your thoughts?
Well, like I said, I try to attend each of the Trenton meetings, and I appreciate that. I feel more comfortable with the guys at those meetings than at some of the AIHA meetings. Again, building science is indoor air quality needs to find a place, and the place is not as a separate discipline. The place should be as a subdiscipline of building science, and there's a wealth of interest today in building science as a means for ensuring the performance of buildings, primarily for energy reasons, but more and more we're recognizing that in order for a building to be sustainable, it has to provide a safe and comfortable and healthy environment for the occupants. And as such, a subdiscipline in building science is indoor environmental quality, indoor air quality, and I think that's where the future is. And it's not with people who know how to run sampling equipment and send it to a lab for analysis. It's with people who know how to go A to Z through a building to ensure that building is performing and functioning as its design intends.
I want to get in one more quick question before we go to halftime. You started out in the outdoor air world and then moved indoor, and you're very, very knowledgeable and experienced in industrial hygiene. I wonder if you could point listeners to where you found the most value in learning about building science.
Yeah. Well, for me, the way that I learned is to recognize that when I go into a building, I'm not the expert. That there's an expert in that building. Somebody knows more about that building than anybody else in that building. And that's the person who you need to be in contact with. If somebody is saying that there's a problem with the building, the first thing you need to do is find out who knows the most about that building and ask them what they think the problem is. And start that conversation with them. And if you go into a building and you think that you know more than the guy that's the facilities guy that operates that building, then you're really not going to get the information you need in order to do your job. So over 30 years, more than 30 years that I've been doing this, the way that I've learned primarily is by letting the guys know that are running the building that I don't know anything about this. You've got to tell me. You've got to tell me how you operate the building. What's right and wrong about the building. Show me where the air handlers are. Open it up for me. So that's number one. Now, today we have some great avenues to gain building science knowledge in these short courses that are provided, for example, to be certified through the Building Performance Institute as a building envelope analyst or a building analyst, to learn how to use pressure measurement, these micromanometers that you can measure pressure differences, tell you which way the air moves. If the pressure's higher, positive pushes, negative sucks, and if you know which way what the pressure difference is between two spaces, you can tell which way the air is moving between two spaces. You can tell, you can use that to help backtrack. So, one good avenue for people that are already in the trades, who are looking at building science as a discipline, a professional discipline, is to get certified through BPI or HERS, become a HERS rater or a BPI, particularly for residential, but also for high-rise residential, and it gives you some tools for doing building diagnostics that are great. So that's where I think is number one. I think that joining the American Industrial Hygiene Association, there's new opportunities in these non-traditional areas of industrial hygiene, like indoor air quality, and that's where there's a lot of conversation. The Indoor Air Quality Association, I think, is probably the best avenue to develop with to be active within an organization like the IAQA, and help move that forward, and help finding opportunities for short courses and training and seminars and going to these conferences is how you develop. And also, the blogs where you can, if you have a question and you're uncertain about where to go, just to let people know that you're uncertain, ask for advice from the industry to be there. But the one thing you don't want to do is decide that you're an indoor air quality expert, that you know a lot, and you use your ego rather than a strong knowledge base to do that. There's some basics that you need to know, like ASHRAE Standard 62, right? The most, and more often than not, when people have a problem with buildings, the problem is an inadequate air exchange. You can have contaminant sources, and sometimes they're difficult to control. Sometimes they're generated indoors. Sometimes just occupancy itself can generate the contaminant. And the way they're controlled is through air exchange and ventilation. And that's a key consideration, that a key knowledge base that an indoor air quality professional has to have, is to be able to gauge the air exchange and ventilation in the space that they're inspecting.
That's a perfect. Go ahead.
Yeah.
Well, that's a perfect place, I think, to cut and go to halftime, because when we come back, I want you to talk a little bit more about that particular topic. I had an email back from our show announcement this morning saying that you'd done a presentation at, I guess it was IAQ 2016, and it was toward the end, and not everyone was still around, and Lou Harriman, who's a legend around here anyway, wanted you to talk a little bit more about that subject. So we're going to stop and thank our sponsors. We'll be back in 90 seconds for the second half of our interview with Cliff Cooper. Our association sponsors include
the Indoor Air Quality Association, a nonprofit multidisciplinary organization dedicated to promoting the exchange of indoor environmental information through education and research. Visit them at iaqa.org.
IEQ Pros, formerly Triska, who have been serving the needs of and advocating for their members for over 30 years. Remember, IEQ Pros is your link to industry's training, certification, standards, and events. Their website is ieqpros.org. And thanks to our advertisers,
Particles Plus, who engineers and manufactures feature-rich particle counters, air quality monitoring instrumentation, and vacuum pump technology. Visit them at www.particlesplus.com. Count on us.
Gray Wolf Sensing Solutions, who use advanced sensor software technology and embedded computers to provide superior environmental test instrumentation. Visit them at wolfsense.com.
We could not do the show without our sponsors, beginning with our marquee sponsors.
John Don Products, where restoration and abatement contractors shop. Visit them at jondon.com. That's JONDON.com.
Healthy Indoors Magazine, a free online digital magazine for industry professionals and consumers. Subscriptions are available at IAQ.net.
Legends Environmental Insurance Services, the experts in insurance for environmental consultants and contractors for over 20 years. Visit them at legends-enviro.com. Okay, we're back for the second half of our interview. We've got Mr. Cliff Cooper here with Vertex Companies. Cliff, before we left, we were talking about ventilation essentially, and outdoor air, and how how that can be so important in helping with contaminants that are developed both that are indoors, and how we can maybe dilute those things. But I got a text question for you that said, if you could, to describe the simple, accurate, and real-time method you developed and used to quantify outdoor air dilution effectiveness.
This is a big topic on its own, Joe, and I'm actually in the morning on the 30th at the conference. I'll be doing a short 50-minute presentation on tracing air in buildings, because it's an important area of knowledge that we all need to develop. If people in a space are experiencing difficulty in the space, then you need to track where the air is coming from that it's entering that space. And there's really two areas that it can come from. One is from the mechanical air supply to the space, and the other is this other area called infiltration, which by definition means, well, we don't know where it's coming from, but we need to track that. And so there's different ways of tracking that. But to go back to your question, this question of ventilation efficiency it's an important question that has no good answer right now. ASHRAE says that you need to account for the efficiency with which your outdoor air supply actually gets to the breathing zone of the occupants in a space. And yet they say you need to do that, but they don't provide a method, because there are no good methods that have been established by ASHRAE at this point to do that, principally because of one problem, and that is that there has not been a tracer, an air tracer that you can label an air mass and measure it in real time as it travels through time and space. The standard is a 1950s method using sulfur hexafluoride as a tracer, which is really a very complex laboratory method, and it only provides averages. It takes about 15 seconds to grab a sample of sulfur hexafluoride to analyze it. And so you need to have sort of steady state conditions and this kind of thing. So what we've done, Vertex developed a real-time tracer that we used initially just to be able to determine the source receptor route, where we have a source, say an odor source is the most common use for it. You have a source of odor, and it's entering a space that's 5 feet away, and so how do you determine how that source got to that receptor, and where did it enter? And so we developed a tracer for that, and it turns out that the tracer is quantifiable. Actually, in America, we can use a photoionization sensor. And Ion Science has been great in helping us with this. We got a grant from NYSERDA to take a look at this to see if we can use this for quantitative measurement of, you can label an air mass and do that. So when I gave this talk at the ASHRAE IAQ 2016, is to demonstrate one of the uses. And one of the uses is you can label it the air mass in the return, and there's a simple mass balance formula that you can use for determining if you know the concentration in the return, there's no concentration in the outdoor air supply, and then you measure it at the return, you measure it at the supply air, you can determine what the percentage of outdoor air is in the supply air using this tracer. Now, I'm going to show a method on the 30th where if you have a good populated commercial space with a fairly steady CO2 generation rate in the building, then you can actually use CO2 for that. And I'll also show how we use our little tracer for that. But this is an ongoing applied research project that Vertex has, is to develop these applications for this new technology, which is for the first time we can actually label an air mass with a green tracer and measure it in real time over extended distances. And so stay tuned for that as we develop that.
What can you tell us what the tracer is? I mean,
Yeah, it's we use a citrus terpene and alcohol. They're natural alcohol citrus terpene mixture that we atomize and measure with a PID, with a photoionization sensor. The first time I used it, I used the multi-ray instrument, and now we're using an IS Science Tiger. So these are instruments that a lot of people already have. They're easy to get them through a rental, and we'll be developing the box that we can release the tracer that people can use. The easiest use, I mean, the most common use for it is going to be to use it as an extended smoke tracer. Instead of smoke you can use over a few feet.
Right.
This we've been able to use over 5 stories. So we have a tracer that we can actually label an air mass, measure it in parts per billion as it moves through space in real time. We use multiple sensors, so we should be able to, and we've been successful in being able to use it for tracing air distribution in spaces.
Interesting. Very interesting. Is there a place where, a blog or a website where you're posting this information for people, or will we just have to wait until it's all done and then get the final?
Yeah, I published it. We published it in the proceedings of the of IAQ 2016 through the Air Infiltration Ventilation Center. By the way, for your audience, this organization is an international organization that is a library of indoor air research that has been doing this for almost 30 years. It's called the Air Infiltration Ventilation Center, and they combined with ASHRAE this in 2016 for this combined conference, IAQA 2016. So in the proceedings of that is where we published this technology, and that's the only place it is right now, because we've been involved in other things. We're primarily a consulting company, and we use it ourselves. But as we move forward, we're developing partnerships to try to get this commercialized as a commercial product.
Very interesting. I look forward to. I'll be there on Monday morning. The 30th, John? Yeah, the 30th. So the first day of the IAQA 20th annual meeting. In the morning, you'll be presenting more on this.
Yes.
Fantastic, yeah. Cliff. Thank you so much, and thanks to Lou Harriman for bringing that to my attention. Let's talk a little bit more about performing IAQ investigations. I'm wondering, is there any specific standard or guideline that you follow and or would recommend that listeners be sure they are either using or at least aware of?
Well, again, ASHRAE Standard 62 provides minimum requirements for the minimum amount of outdoor air that should be supplied to an occupied space. And I think being familiar with that is important, because again, ventilation is a primary data requirement if you're going to do an indoor air quality investigation, to ensure that you're getting air exchange ventilation. So that's number one. So this idea of primary data is most important, and that is that you first need to ensure that the air that's being mechanically supplied to an occupied space is clean, free of contamination, and is actually getting to the space. So you start by, and again, the idea of an indoor air quality investigation, not measurement, it's primarily it's inspection. And so start by looking at the outdoor air intake. Is there a dead pigeon in the outdoor air intake? Is there a contaminant source that's directly impacting that outdoor air intake? You look around, do you see a smokestack that's 20 feet away? Do you see a
sewage plant,
any kind of exhaust source, any exhaust source
yep.
There? And then you go from there. You go from the outdoor air intake to the mixing box, and that's where the return air is mixing with the outside air. And then you look at the coils and the filters and the condensate pan and the fan and the air ducts. Is there fiberglass lining in the air ducts that's friable, that's throwing fiberglass through the duct? You go to the VAV box supplying it. Is the VAV box actually supplying any air at all when there's no thermal demand to the space? You look at the returns. The plenum return, is the plenum clean? Is the return air duct clean? Because that's providing supply air again. It's being returned and providing. So that's primary air. If people are concerned about the environment that they're living and working in, and you can tell them, we've looked at it, that the air that's being supplied is clean, then you've gone a long way to reducing the angst that these people have for their reporting these problems with air quality. At least you know that the air that's being distributed to the space mechanically is clean, and that takes one thing off the table. And then you can look at other things like local sources or infiltration sources. But that's primary. That's a primary component of an indoor air investigation, is that physical inspection, to visually inspect. And that's what, again, going back to 1984. Well, I went into indoor air. Outdoor air, you've got no control over where the air is coming from, going to, and where it's being distributed. When you're in a building, you're in a box, and you should be able to put your finger on every location where air is coming in and out of that box, and that should be your primary objective when you get in there.
Great stuff. Cliff, let me turn it over to you. Z-Man.
Thanks. Well, we're kind of getting short on time, and I do have a question that I would like to ask, because I'm interested in, and I suspect that our listening audience would be as well. Based in New York City, there's a lot of celebrities, there's a lot of famous people. I just wondered if you could tell us about an opportunity that you had in either working in a famous building or working for a celebrity that's noteworthy.
Well, I work in. I've done work in properties that are very expensive properties, residential units, and the thing about New York City is that if you live in New York City, whether you live in the most expensive building or a standard building, you're living indoors. Everything that you own is either in your apartment or it's in a little storage area in the basement. And it's fascinating that you can go into these multi-million-dollar properties and you open up a closet and there's nothing but storage, top to bottom, in the closet, because they all have to live indoors. It's all living in an indoor space. And to me, that's the most interesting aspect to it. My interest is not so much residential. The problem with residential investigations is that occupant behavior is often the dominant source of contamination in residential buildings. You don't have a mechanical air supply that's bringing in outdoor air. Typically, New York State building code doesn't require outdoor air supply. There are very few buildings in New York City that include an outdoor air supply in the residential space. So we have stack effect and occupant activities are the primary components to affecting air quality in these spaces. I so much prefer commercial spaces because you have much less variety of occupant activity. When they go in, people in commercial spaces are usually doing office stuff, while in a residential space, you're doing everything. You're shaving, you're showering, you have a hobby, you're cooking, and all of those can be confounding influences when you're trying to determine why there's dissatisfaction among the occupants there. So, that said, I did, I've done work in buildings that where people that have some fame are. But again, it's the building is the reason why I'm there, and not the owner.
Right.
I'm curious, Cliff. You probably look at a lot of reports, see a lot of reports. Any tips you could give listeners for how they could do a better job on report writing?
Yeah, sure. I could spend hours on it. The first is, before you, when you first get the gig, make sure that you have a statement of what your objective or objectives are for being there. Your objective is to inspect the space in response to an occupant reports of dissatisfaction with air quality, and then to go, in a linear sense from there. My objective is to investigate an occupant report of poor air quality, and then the next statement should be, based on that objective, I will carry out these tasks. And you write down task 1, task 2, task 3. I'm going to inspect the air handler. I'm going to talk to the facilities manager, and you get an outline of everything that you're going to do while you're there. And then when you prepare your report, you take that outline. In fact, that outline can start out as a proposal that you're getting the authorization to be there.
Yep.
And then from there, that becomes the basis that you fill in for your report. So the important parts of a report are: what was your objective? What were the tasks that you filled out to address that objective? And what were the results of each of those tasks? And then based upon those results, what conclusions do you draw from it? And then following that, what are the recommendations based on the conclusions? And each one should be supporting the section before. Your recommendations should support your conclusions. Your conclusions should support your observations and measurements from your tasks. Your tasks should support the objective.
Beautiful. That's a nice, quick, and concise summary of a proper report. Let me ask you this: on mold remediation projects, do you have a post-remediation verification? Do you have a? Well, let's put it this way: what should be part of that PRV?
Well, it's a great idea to have a third-party inspection following remediation prior to putback. And that inspection should be to ensure that all damaged locations have been addressed and remediated. And that's it. That the damage conditions have been taken care of, and that the source that resulted in the damage has been remediated. Remediation is not removing the dry sheetrock. Remediation is removing the dry sheetrock, finding out why it was, the wet sheetrock, finding out why it was wet, solving the problem that caused it to be wet. Then you've done your remediation. And then all it takes is a third party to go in there and say, yes, he did that, he or she. Removed the damaged materials, resolved the condition that resulted in the damage. That's the verification. It's typically a visual inspection. It's a review with the contractor, talk to the contractor, what the contractor found, what the contractor did, and then to make that determination that it was sufficient.
And then you get the building owners and property managers and residents that want some kind of testing. Any recommendations on that?
I'm perfectly willing to do mold sampling. I'm just not willing to give an interpretation of what those results mean. So if they want mold sampling, I can provide them. But if they want me to interpret them, the only interpretation there's only two interpretations that you can do if you're forced to do a mold sampling. One is that I came back and I saw that everything was done properly, and I took the mold samples, and the mold samples showed no issues. So I can say my conclusion is that the mold sampling is consistent with my observations. The other is that there was some anomaly in the mold sampling, that the mold sampling, the outdoor air was lower than indoor air, for example. And I can only conclude there that I need to go back and resample, or that the mold sampling that's really the only conclusion you can do. If you do a sample and you get an anomaly, it's your responsibility to go back and find out why. And you can go back in and say, well, there is nothing there. I did the mold sample. The mold sample showed it was higher indoors than outdoors. Then I went back and I looked, and I said, there's nothing there. So what do you do again? You sample again. And then what happens then? Well, if the sample is negative, you're done. If the sample, you still have the anomaly, you've got to go back in and take another look and see why is it that way. Again, one of the big mistakes that are made by people in this industry is that they say mold is the problem and we're going to remediate mold, which is absolutely incorrect. If mold exists, the mold is an indicator of a problem. Mold is not the problem. Mold is an indicator of the problem. The problem is the damage condition that resulted in the amplification of these organisms. And so if you're a mold inspector, your objective needs to be to identify the conditions that could promote mold growth. You can go into a building that has water damage and has no visible mold growth at all, and that your testing is not showing any amplification at all, and you still have a potential mold problem because you have the damage condition. And because you're not getting any amplification today, it doesn't mean tomorrow that you won't have that amplification, because the conditions are there. And it's those conditions that have to be remediated. You don't remediate mold, you remediate the conditions that can result in mold.
You know, do you have an extra 5 minutes, Cliff? We're running a little short on time.
Sure, no problem.
All right. I'd like to get two more questions in at least. One of them is, well, let me skip that. Let me go to the next one here. I've got a question on here about research. I noticed that one of the reasons you came to my attention is I watch LinkedIn and I see people, posting and putting things up there, and oftentimes they don't have anything to back it. And you've been very polite about it and just say, well, what's your resource on that? What's your source? What's your reference, etc. And a lot of times people can't come up with that. I'm wondering if you could point to any more recent research that's kind of changed your thoughts on indoor air quality investigations.
Sure. One of the most exciting things that we're seeing now is this new research on microbiomes. So we tend to have a simplistic attitude about the microbiology of indoor environments. That, well, we only have microbiology when there's a damage condition, when there's water damage, then we can have this microbiology. And the microbiology is primarily mold. In reality, we have a very complex biological micro environment with all kinds of organisms that exist in the air. And we're starting to, with the new technologies, with our DNA sequencing technologies, we're starting to be able to characterize different environments according to their complex microbiome. And I suspect that in the next few years, we'll be able to go in with much more sophisticated sampling, that we can actually tell by the mix of organisms that we're seeing whether a environment is typical or atypical. And so this idea of microbiomes, I think is going to be, it's going to revolutionize how we measure the biological component of the built environment. So that's one area. The other is that we've got some recent research that shows how the current methods for measuring are so unreliable that we can, most of you guys, us guys out there that are taking these biological samples, are taking a single sample indoors and a single sample outdoors, or maybe we'll take a single sample at different locations indoors, but very rarely are we taking two samples at the same location. And the research shows that there's so much variability in sample results, just in the methodology itself, that you need to have a lot of samples just to have any significance, to understand what the, is there a difference between two samples? you need to have multiple samples to do that. So I think that, recent studies that have been published are really pointing to this idea that spore trap sampling is an unreliable indicator of what's going on in the indoor environment. I think any of us who've been doing this for a while get surprised when you can visibly see a substantially damaged environment with visible mold growth, extensive visible mold growth, and then you take a sample, and the sample is negative. And all of us have been there and seen that, and so we need to move away from spore trap sampling as a primary means of characterizing indoor environments, and rely until we get this microbiome methodologies developed, which is probably 5 years away. We need to recognize that we need to be relying on is visual inspection, moisture mapping, and knowledge of building science to know when there's a condition that could promote this kind of abnormal mold growth.
And before we go, we always like to, and it sounds to me like you kind of combined two answers for me there. I was looking at any new issues that you see on the horizon, and you mentioned the microbiome. Any others with respect to indoor air quality that you see is up and coming that people should be aware of?
Yeah, there's a big problem that I think is facing us head on right now that people don't really recognize, primarily in commercial buildings, commercial high-rise construction. In 2010, for the first time, International Building Code and adopted nationwide in the U.S. requires tight building envelopes for commercial construction, and commercial buildings have never since we've been using variable air volume control in buildings. We have not done a good job of providing ventilation air in buildings through the mechanical air handling systems, and now with this move for higher performance in buildings, we're going for things like occupancy sensors for demand controlled ventilation, passive ventilation, with sealing up these building envelopes, we're eliminating what has been a major source of makeup air and air exchange in a building, which was infiltration air. And I think that we're going to see more problems with new construction than we have in the past, because we're still relying on variable air volume control in buildings that are based on temperature sensors only as the primary way of controlling the ventilation air supply. And we're not measuring the outdoor air portion well in these buildings. So I think that's an upcoming issue, is that I think that some of these new buildings that we're coming with tight building envelopes are not going to be providing sufficient ventilation in these spaces.
Interesting. Z-Man, you got a final question?
Yeah, just as kind of a follow-up, Cliff, on the subject that we were talking about before when you were talking about microbiome and so on and so forth. I was wondering whether you have an opinion either way on the use of ATP for post-remediation verification.
Yeah, this is the quick sampling for genetic markers for organisms. Is that what you're saying?
Yes.
Well, yeah, it just uses ATP, and you end up with a number. So
right. Oh, ATP. Right. Yeah, we had a little blog discussion about this last month. I think it's interesting. In clean rooms, it's these little ATP. You can do, I guess, swab samples or surface sampling for ATP, which would be the indicator of biological growth. I'm not the expert on this. It's one of the areas that I'm curious about, and I'm listening to what others are saying about it, and there seems to be some indication that, in a controlled environment, this could be worthwhile. A lot of the sampling, a lot of environmental sampling, has its best use not as an absolute, but as a relative measure. So, for example, if you're looking at particulate loading in a clean room, what you can do is start measuring and get a baseline. And then all of a sudden, if you see a change in a particulate level, then you say, oh, we must have some breakthrough in our HEPA filters or something like that. So, using methods like this, these quick methods, could be useful if you get enough experience using them that you can tell when something is significantly different. And so I think it has potential, but I think it's something that you need to sort of develop experience with. And I don't have any experience with it. I've never used the technique myself.
You answered the question for me because something never really clicked with. I couldn't figure out why, and you answered it, and I appreciate that. And your answer was that, and I wrote it down, that it's worthwhile in a controlled environment. And my issue is a bathroom in one school versus a bathroom in a different school in a different city. I don't necessarily know that they're related, but I think the data that you have, in each bathroom separately, I think could be very, very valuable. And I appreciate you clearing that up for me.
Yeah, maybe a good example might be if there's been a sewer spill, that you can do a pre-remediation, post-remediation, and see that you have a lower level after cleaning, for example. It may be it could be used as a clearance tool if you do the sampling before you do the clearance, and then after.
Right.
Well, before we go, is there anything you'd like to add or anything we missed that you want to make sure listeners hear?
Well, Joe, I'm looking forward to seeing you on the 30th, and I'm hoping that anybody that's listening who's going to be there on the 30th comes up and introduces yourself, and I hope that your listeners become active in the IAQA, because I think that this organization has got the best potential for representing this industry moving into the 21st century.
That's great to hear, and I look forward to seeing you as well, and getting a chance maybe to step off to the side after your presentations. I guess you've got two going on there, huh?
That's right. I got 8 a.m. on Tracing Air, which is a 50-minute intro, and then a 2-hour workshop on IAQ investigation.
I'll look forward to seeing you there, Cliff Cooper, and thanks for joining us today on IAQ Radio. Also want to thank my co-host, the Z-Man, Cliff Zlotnick, at the controls. John, you got to have faith. All went well. Most importantly, our growing group of loyal listeners, and want to thank the IESF folks, and play their commercial one more time before we go. Hope to see a bunch of you at the IAQA conference the end of January and the Indoor Environmental Science Forum. I think it's the third week of February. This is Radio Joe saying thanks to all the listeners. We'll see you next Friday for the next episode of IAQ Radio.
Coming to the Doubletree Hilton Hotel, Tampa Airport in sunny Tampa, Florida, February 21st through the 24th. It's the second annual Indoor Environmental Science Forum. Join industry leaders and educators as they share their knowledge in supporting science with you. Speakers include Pete Consigli, John Lapeterre, Dr. Ralph Moon, Harvey V. Cohen, Joe Hughes, Cliff Zlotnick, Ken Larson, and Eric Shapiro. See the latest equipment and solutions from exhibitors. Network with sponsors and industry insiders. It's 2 full days of in-depth coverage of water damage, assessment, protocols, mold remediation, problems, solutions, and legal issues. Don't miss this important 2-day industry forum beginning Tuesday the 21st with a welcome reception and wrapping up with a live IAQ radio broadcast Friday the 24th, featuring Radio Joe and the Z-Man and their guests John Lapeterre, Richard Alexis, and industry watchdog Pete Consigli. Register now at indoorenvironmentalscienceforum.com. That's indoorenvironmentalscienceforum.com, or call 954-562-6093 for more information. Register now for the second annual Indoor Environmental Science Forum in sunny and warm Tampa, Florida, February 21st through the 24th.
This has been another IAQ Radio production.